Well, hello Internet, and welcome to my Crystal programming tutorial. In this one tutorial, you're going to learn the core syntax of the Crystal programming language. And basically, Crystal utilizes code that is as easy to understand as Ruby, but has the speed of C. And you guys requested it, and so here it is. In the description underneath the video, you're going to find a extremely detailed cheat sheet as well as a clickable table of contents so you can jump to exactly that part of the video that you are interested in. And now I'm going to show you how to install it. Okay, so here is the Crystal site, and to install it, it's very easy. I'm not going to run through it. You just click on install here, and then you pick your version of either Linux or Mac OS for this to run on. And also there is a bash system if you want to run Windows. So it's really, really simple. You just get in here, click it. Yeah, as you can see, very, very simple to install. All right, so now I'm going to jump over and get into the code. Okay, so basically I have Atom installed here on the left, and on the right side of the screen I have my terminal. And in regards to packages that I have installed, if you come in here to packages and command palette, click on that, and then you click on install, you're going to see install packages and themes. This is if you want to use Atom like I'm using, and then you can come in here and type in language Crystal actual, and this is specifically what I have installed on my system. So that is if you want to do exactly what I'm doing. All right, so basically let's do a hello world. Very, very simple. We're just going to go hello world with puts in front of it. And if you understand Ruby, you pretty much understand Crystal. And then you're just going to, in your terminal, type in Crystal and then whatever the name of your file is, and then followed with CR. And you're going to see here that it's going to compile and print out hello world. Okay, so we got that out of the way. Let's also get comments out of the way. You just put in a hash symbol or a $, whatever you want to call it, and that is a comment. Now what I'm going to do is talk about data types. It's very important to understand that everything inside of Crystal is an object, and your variables are either going to start with underscores or they are going to start with some type of lowercase value. After that, they can then contain numbers, of course. If you want to have a constant, you just put uppercase all the letters, and there you go. Now you have a constant. You can also do multiple assignments. So let's say you wanted to have A and B, and then you wanted to initialize A with a value of 1, and then B with a value of 2. That's how you could do it. Of course, you can do single assignments as well, and that's how that is done. Booleans are going to either be a true or a false value. So we could say true or false, and lowercase letters like that. And then let's get into some different integer types. Of course, integers are going to be data types that do not have a decimal place. And you can get the size of these different types in regards to bytes just by going int and 8. This is a 1 byte integer, and there's a couple other ones. There's also going to be 16, and there is also going to be 32, and there's also going to be 64. And then you're also going to have unsigned versions of all of these different guys just by putting a capital U in front of it. And if I go over here and run it, you're going to see we go from 1 byte the whole way up to 8 bytes. There are 2 different floating types, and you have a float 32, and you're also going to have a float 64, and they are going to be accurate up to about 13 digits. I can show you an example of that. This is true of all programming languages. They all eventually mess up if you have a value that is too big. So let's just go in here and throw that inside of there, and that would be a floating point value. And then let's go puts, and then I'll show you where it fails. So we'll go big and float that, and then we'll add in, these are going to be 14 decimal places, what I have right here. And I'm just doing this for demonstration purposes. And you're going to be able to convert from a floating type or to an integer type into a string just by going to and then underscore s. And if I go over here and run that, you're going to see the value that comes up, and everything is perfectly fine until we get right here to anything past those values. So I just like to always point out that at some point, if you perform any type of multiplication on floating point values, that you may get inaccurate results. And that's, of course, true of all programming languages. We also have characters. So we'll have my grade, and they are surrounded by single quotes instead of double quotes, as you're going to see with strings here in a second. And you're also going to have special characters inside of Crystal, just like all programming languages. So you can have new lines, and you can have tabs, and if you want to backslash out a single quotes or backslash out a double quotes, those are also available to you. Now let's talk about strings. And of course, strings are just going to be a series of characters that are going to be surrounded by double quotes. And there we are, we just created a string. And of course, there are no semicolons, and there are also no curly brackets inside of Crystal, just like Ruby, because we're going to use white space, as you're going to see later on, to define our blocks of code. So let's say I got number 1, and let's go and get number 2 like this. We're going to be able to perform string interpolation just by going in here and typing in puts and then double quotes and then a hash symbol. And let's say we want to get the value for number 1, and then we want to throw in the string part there that's going to represent the addition value. And then we just go and surround everything that we want presented as the variable's value with the hash symbol and the curly braces. And also we're going to be able to perform calculations directly inside of here. And we can number 1 plus num2, and we could throw a new line in there. Well, let's throw a new line in there just for the heck of it. And you can see there are the results that we would expect. There are no multi-line comments inside of Crystal like there is in Ruby, but that might change at some point. But there are multi-line strings. And how you create one is you could just come in here and you just create it. So let's just go in here. We could say something like, I use many lines, like that. And if you go and try to print that out onto your screen or inside of your terminal, you're going to see that it holds up. Every place that you put a new line inside of the multi-line string is also going to show up in your final output. You're also going to be able to perform a string concatenation just by using a plus sign. So we can just come in and go like this, and if I can spell my name properly, there we are. And let's go and do a couple other different things. You're also going to be able to get the size. So let's come in, we'll throw egg inside of there, followed by size. And let's say we wanted to duplicate a string multiple different times. So we wanted to triple the amount of money we have. No problem. Inside of Crystal, we can do that. And if we run it, you can see right there that we did it. We could also do a whole bunch of different comparison options between our strings. So we could say something like, does the string Doug equal the string Paul? And there's another way we could also compare. We could also come in and go puts, and we could say Doug, and once again, instead go compare and type in Paul in that situation. And you can see right here we have false. And in the situation in which Doug, the letter D in this situation, comes before P, we're going to get a -1. In the situation in which they would be equal, you'd get a 0. And in a situation, let's say we had Paul over here and Doug over here, in that situation, you would get a positive value in that comparison. There's going to be different ways you can access individual characters. So let's say we had hello inside of here, and we wanted to get the very first character inside of hello. That's how we could do it. We could also come in and go put, and let's say we had a string of monkey, and we wanted to say index, and we wanted to get the index where a value is inside of a string. We could do that as well just by coming in, and let's say we wanted to get the key part of monkey. We can also find out if a string contains another string. So we could go turtle dove like this, and we then go include, followed by whatever we are specifically searching for. So dove, let's in that situation. We're also going to be able to get ranges of values. So let's say we have Pigman for some weird situation. We are going to be able to go and get from the first or the 0 index for our string the whole way through the second one. We can also, well, let's go and run that just so you can see it. Whoops, got an error. I was supposed to type includes. What was I doing? And there you can see H, we grabbed the first value, we grabbed the index where the key starts, we found out the dove was inside of there, and we printed off the pig from the pig man. We're also going to be able to convert from strings into arrays, and we can demonstrate that just right here. So let's say we wanted to go Sue, and we wanted to turn this into an array of characters. Could do that, and we could also return an array using a specific separator that we define. So we could say happy birthday, and then call split on it like this. And then we could say that our separator would be a space. Another useful thing is we can count the number of times a character is specifically used. So let's go and use my name again and say we want to find out how many times a character of E shows up. We can of course check if it is empty. So we could say puts, and we could say empty after that, and then throw in a question mark. Let's keep going. We could also replace a substring with another one. So once again, I'm just using puts here just to output information. So we could say something like have a good day, and then we could go G sub and replace good. It's going to automatically search for it. And instead, we could be a little bit pessimistic and say okay day. And since we're inserting values, let's do another one. We could also insert inside a string in this way. So we could say something like have a day, and then follow that up with insert. And then we could say we want to start at the 6th index, and it's going to automatically give us some room inside of there. So we can change that to good. And if we run all this, you're going to see it went and created that array. Whenever we said how many E's are there, there's 2. Is it empty? It came back as true. Have a, and we replaced good with okay. And you can see right here, have a, well, I should have put a space inside of there, but you can see that I was able to insert that value as well. Now, since we've been talking about arrays, let's go and cover some things we can do with arrays. And of course, arrays are just ordered lists with integer indexes. So let's go and let's create an array. And this is how we do it. And we'll just throw in some random values inside of here. You're going to be able to also, don't want to miss this, go and put multiple different data types inside of your array if you would like to. So you can throw a word inside of there, as well as 3.2, all valid array types. You're also going to be able to define accepted types in an array and throw an error if they try to store something you don't like. So let's say we would go in here and we would create this array, but we would say then that we want to be able to accept either strings inside of this array or, of course, int 32 data types. That's how you would do that. Nothing else would be acceptable. You could also come in and create an empty array. So how you do that is you would say array, and then you're going to define the types that you would like. Of course, you could put or symbols in there if you would like multiple different ones, and define new. So there's another array. You're going to be able to assign values to an array using a separator, just as we had previously seen. So let's say we go and create an array called names, and we want to automatically split those out based off of the comma. There that is. You're going to be able to get the size for an array. So we'll go array1 and size, just like you did with the strings. You're also going to be able to get a index value, just like you did previously with our strings, just like that. And that would give you the second value inside of the array because they're all 0 indexes. You could get from one index to another one. So let's say we wanted to do something like puts, and once again, array1, and you wanted to start at 1 and go through 4, you could do that. And let's run this just to see what we got. So you can see 4379, it went and grabbed those different values, 4379, just like that. You're going to be able to get the last value also inside of an array just by coming in here. Whoops, make sure you change that to 1. And of course, the name doesn't have to be array. I just typed that in. So that's going to give you the last value. You're going to be able to remove the last value, or actually, let's go in and let's add in a value first. So if you wanted to add a value, let's say that value is 10, that's how you could do it. And then now what we'll do is we will come in here and pop off a value, which is going to be our last value. And here you can see that is another thing we can do is we could remove the first value as well. So we can go array puts array1 and shift. That's going to give us what we were looking for. We can check if a value exists, once again, just by going puts and array1, and follow that up with includes and a question mark, and let's say we were specifically looking for 7. There it is. We could delete values, of course, by just calling delete, and then the specific value you want to delete, which is 7 in this situation. We could delete from one index to another index. So we can go array1 and delete and at, and then you could go from 0 through 2. We could then come in and insert values also. So we can say puts and follow that up with insert and where you want to start inserting and what specifically you would like to insert. And there you can see all of those. And you can also see that it returns values in these situations whenever we call these specific functions. Let's continue doing some more fun stuff here. You could also push on multiple values. So I'm going to go push array1 followed by push, and let's say just 4, 5, 6, and 7 just to keep it simple. We could sort these values then, and so we can go array1 and sort, and we can keep on going. We could return only those values that are specifically unique, so array1 and followed by unique abbreviated. We can perform, let's go and run this and then we'll show you some other stuff. There you can see all of the output that we received, and here you can see that in this situation we sorted those values. Now to do something really cool, we're going to be able to do operations on multiple different values inside of an array. So we can do something like puts array1 and call map, and then on map what we're going to do is we're going to say that we want to give temporarily the value of each of the individual parts of the array. I'm putting or symbols inside of there, and the value of x, and then we want to multiply all of those times x. We can do so, and here you can see that we were just very easily able to create a brand new array that is based off of that multiplication. We could also return an array of all permutations, so all possible values for whatever we're working with. So let's do array 5 is equal to, and create an array 1, 2, 3, and let's work with this one instead of our bigger array, which would give us a bazillion different permutations. So we could say something like array1 and permutations. If you don't know what permutations means, well, you will now. So now what we can do is run that inside of there, and whoops, what did I do? Oh, I typed in that instead. So let's turn 5. As you can see, it got really big. Then we'll run this inside of there, and you can see all the possible different versions using all those individual different numbers inside of their array. So if you wanted to go and break into a keypad, that would be something you could use. And of course, to finish it off here, we can output all the values in our array. So we're going to go array1 and each, and then you go do, and then you define the variable name for each part of the array as you pull it out. And then in this situation, all we are going to do is print that out on our screen, and we can end that like that, and we could run it like this, and you're going to see it prints all those out. So there's a rundown of a ton of things we can do with arrays, and now I want to talk more about looping. Alright, so what I want to do here is I want to show you how to print all of the even values from 1 to 10. I think that's a pretty good example. So we're going to create a variable with value of 1, and what we're going to do is we're going to go loop do, and then we're going to use a shortcut way of doing an addition on a variable. Of course, this is just exactly the same as saying x is equal to x plus 1, okay? And you can also do that with multiplication, subtraction, and division. Now, inside of here, what we're going to do is we are going to say that we want to skip the rest of the loop unless the value is even. So we're going to say next and unless, and then we're going to say x and modulus, which is going to give us the remainder of a division in a situation in which the modulus using 2 is going to give you a value of 0. In that situation, you know you are dealing with an even value. And then what we're going to do is we're going to say puts x. So we're going to output x. So if it hits next, what that means is skip the rest of the stuff in the loop and come back up here and loop again. Then what we're going to do is we are going to have to define when we exit. And when we specifically are going to exit out of this looping structure is in the situation in which x has a value that is greater than or equal to 10. So we'll say break if x is greater than or equal to 10. And then we are going to end our looping structure by typing end inside of there. And you can see if we run it, it's going to print out only the evens. Now what I want to do is I want to show you how to do this in multiple different ways. So let's say we want to do this also with a while loop. Well, in that situation, we're going to replace a couple different things. We're going to say while and x is less than or equal to 10. Then what we can do is x right here, that's perfectly fine. We can use the unless again. We can output the value. But what we're going to say is we're going to say break if x is greater than or equal to 10, exactly the same as before. So we can go and we can run it, and you're going to see you get exactly the same output with the loop versus the while loop. Now what we're going to do is loop in another way. Here we're going to loop until a condition is met. So we're going to change this from while, and then we're going to change it to until. Then what we'll say is x is greater than or equal to 10, and then we'll continue executing all of this again. Next, unless, and all of this can stay exactly the same. Puts, and x is going to output that onto the screen. We don't need the break statement in there in this situation. Everything else is exactly the same. And if we run it, you can see we're able to output all of those even values in exactly the different ways using multiple different looping structures. And that brings us to conditionals. Now we are going to have multiple different comparison operators, equal to, not equal to, less than, greater than, less than or equal to, greater than or equal to, as well as our logical operators, which are going to be and, or not. And I'm going to demonstrate exactly how we can use these. So let's say we wanted to figure out what grade a student would go into depending upon different conditions, which mainly is going to be the age. All right, so we're going to say if age is greater than or equal to 5, and so we have to have both these conditions are going to have to be coming back as true for this to work, and the age is less than or equal to 6. Well, in that situation, we're going to output you are in kindergarten. All right, so we got that all set up. Then we're going to type in ls if like this, and we can throw in another condition. So we're going to say age is greater than or equal to 7, and age is going to be less than or equal to 13. Well, in that situation, we're going to say puts you are in middle school. And we can continue putting in different conditions. And of course, you could have multiple different lines of code inside of here. You don't have to just have that. And then we're going to go ELSIF once again. And let's throw in another condition. Here we'll say age is greater than or equal to 14. And age is less than or equal to 18. In that situation, we'll say puts once again. And we'll say you are in high school. And there we will have that. And of course, we're going to then follow this up with else, and we will say puts stay home. All right, so there we are. And of course, we're going to have to end this with an end statement. And if we run it, you're going to see you're in middle school comes back for the age of 12. All right, so that's a rundown of those. Let's cover the other logical operators I haven't covered, however. So we can say puts, and if you say true or, false, like this, is equal to, we're going to be able to concatenate this together, and then we'll just say true and throw false inside of there like that, and convert that to a string. And let's go and also cover the not symbol. So we'll say puts, and once again, in this situation, we will do an exclamation mark, and true is equal to, and then we can follow that up with the actual value, which we will get just by running it exactly like we said. And then let's convert that to a string as well. And if we run it, you're going to see that if you have true or false, it's going to come back as true like we would expect. And anytime you put not in front of a Boolean, you're going to get the opposite of whatever you put inside of there. Now we can also perform comparisons using unless. So we can say something like unless age is greater than 4. Well, let's go and put age inside of here and leave it as 12. So unless age is greater than 4, what we're going to do is we're going to say puts, and we're going to say no school, like that. And then we can throw else inside of there, and then we could go puts, and we put an alternative, which would be go to school, like that. And that's how that works. And of course, end that with ends. Let's also go in and cover the case statement, which is going to be used if you have a limited number of options. So what I'm going to do is I'm going to go and throw out different ways of saying hello in multiple different languages depending upon situations. So here, what I'm going to do is say print and language, and then we can go lang, and we can get input from our user by just calling gets. And I'm going to show you a bunch of different ways of getting input from the user. So we'll say then case the value for lang when it is either French, and you could put multiple different conditions inside of here, or French, like that. In those situations, we are going to say puts, and we'll go bonjour, okay? And then we're going to throw in exit, and you have to do that because if you don't, it's going to check the next condition. So it's best to put the exit inside of there. Then what we can do is we can say when and throw in another condition, or we could say Spanish like that. In that situation, we'll go puts and hola, I believe that's how you pronounce that. And then we could also do a default, and the default is just going to be triggered by typing in else and puts, and then in that situation it'll print hello, and then we can end the whole entire thing like that. And then we can run it, and it's going to say language, and if I type in French, it's going to give me bonjour, and if I type in whatever, I'll just put H, it's going to give me hello. All right, so there you go. And now you can see how to use unless as well as case. Why don't we do one more here? There's also the ternary operator. So we'll have, let's just have the age be equal to, let's change it to 55 just to do something a little bit different. So 55. Then what we're going to do is we're going to say puts, and if the age is greater than or equal to 50, and then we'll put, that's our condition. If that comes back as true, it's going to output old. Otherwise, it is going to output young. Hopefully I didn't offend anybody out there. I am not technically old yet, but I'm getting there. All right, so here we are. And old comes back as an example. All right, so there's multiple different conditionals that are available. And since I talked about it, I'm going to talk now a little bit more about user interaction as well as some math functions. Okay, so here what we're going to do is we're going to ask the user to enter two different values, and then we're going to perform different math calculations depending upon those values. So we're going to say enter a value like that, and then we want to get some information from the user. So I'm going to store this in N1, and again we're going to call gets. But in this situation, we're going to type in not nil followed by an exclamation mark. And not nil is going to provide us with a way to handle nil inputs or lack of a value. And we're going to cover those a little bit later as well whenever we get into exception handling. So I'm then going to come in and do the same thing. I'm going to say enter seconds value, and then we'll do n2 is equal to gets and not nil, because we want to try to perform an operation on something that doesn't exist. Okay, and then what we can do is use string interpolation to go and output this information. So hash symbol once again, curly brackets, and we'll throw n1 inside of there, and we can perform addition, of course, which I think I've already done, and n2, and then we can say that this is going to be equal to, and then we can go and do the operation right inside of here. Now, whenever you accept that input, you're going to receive it as a string. So if you want to convert it to an integer, you're just going to take the variable that you have, go to and underscore and I, and there you go. Now you have an integer. And then we can do exactly the same thing for the next value, right like that. And the other different ways to cast two different types, of course, we already saw to string and to integer. There's also going to be to float, and then you can also go to float 64 and to integer, a 64-bit integer, and so forth and so on. So I think you can work out all of those different things, but there is most of them anyway, just so we see it. And you can see that if we run this, that it's going to give us a value, and we can put those values in there, and it's going to calculate them. Then what I did was I went ahead, so you don't have to watch me type this out. Here we're performing a subtraction, multiplication, division. This is modulus again, that gives us the remainder of a division. We can take a value to the power of another value. We're also going to have all these numerous different trig functions that you can see right there. Cosine, sine, tangent, arc, cosine. And all of this code is available in the description, by the way, and it's all free. We can also get the square root, cube root, hypotenuse, different forms of logarithm. We can get the max or the minimum of two different values that are passed inside. And if we come in here and add these values inside of there, you can see how we were able to get all of those different values for all of those different math functions. And now what you can do is pause your screen or get the code, like I said, in the description. Or now I'm going to cover hashes. Okay, so a hash is just a collection of key value pairs, and how you go and create one is you just give it a name, curly brackets, and then you're going to define the keys, and then follow that up with the values. So we'll go 3.14, and we'll go call this guy golden, and that works fine. 8, and then we can go and put E inside of here just so we can have a couple different values to work with. All right, so there we go. We just created a hash. Now what we want to do is go and work with it. So you're going to be able to go and use a key to get a value that you would like, just like this. And if we run it, whoops, I went and change that to uppercase letters. All right, perfectly fine. And now if we run it, you're going to see it went and got the value using the specific key that we had. We're going to be able to print out keys as well as values. So we can go end hash like this, follow that up with each, and then do, and then we'll define the key, which is going to be whatever the first thing is, and the value, again with an OR symbol at the end there. And then we can come in and output that. So we can say key, and then we can say to string, convert it into a string, and then we can go and put like a colon inside of there, and then go and get our value, and once again to string, and then that is going to output the keys as well as our values, as you can see that it did right there. And let's keep going. We can get the size of our hash. So, and we can add that in there. So we'll go hash and follow that up with size. And then let's follow that up to string, and let's do some more. We can check if it is empty or not. So we can say puts and in hash and empty and a question mark. Let's do some more. We could also check for a specific key inside of it. So has key, as you might guess, with question mark, and then we'll throw pi inside of there, do a couple more. We can check if a value exists or not, and we can go has value, question mark, and throw a value we're searching for inside of there. We're also going to be able to merge hashes, and this is also a way to add another hash to our hash. And so let's say we wanted to do something like, I don't know, absolute 0, just to throw something inside of there. And I think it's -459. You can tell me in the comments if I got absolute 0 wrong. Anyway, we throw all those in there and run it. And what do you mean? Whoops, I went and did that thing again. Let's just go in here and change this to that and run it. And there you can see that we got all the different things that we wanted. Let's keep on going. We're also going to have other different functions available to us. So let's say we want to get a hash without the keys. Let's go and hash and reject and pi. So that's, we want everything except for pi. We could also return based off of different conditions. So we wanted to do a value condition in this situation. We could do so. We could say select, and then we are going to put our condition inside of here. So we're going to go and put our OR symbol and K and value and close off the OR symbol. And in the situation in which V is greater than 2, we're going to be able to output all of those. We can remove all but a specific given key. So let's say we want to keep pi, but we don't want anything else to show up. We just go and reference our hash and select and then the specific key that we want to keep. And we can also, of course, delete keys. So we'll go delete, and we will throw in pi to get rid of pi. And let's do another one. Let's do delete if, and the specific condition in this situation, we're going to go put an or symbol inside of there, and then we'll say key and value or symbol, and we'll say key dot starts with, as an example, and we'll say that it starts with the letters G and O. And then one of the final things we can do is to just clear the whole entire hash. All right, so there is a lot of different things we can do with hash. And if we run it, you're going to see all of the different results that we have right there. So there are hashes, and now I want to talk about tuples. All right, so a tuple is going to be fixed in size. However, it is going to have the ability to hold multiple different data types. And how you create one, let's go and throw some information in here about me. So I'm going to go Derek and 43 and 174.5. I'm very embarrassed. Now you know how much I weigh and my age. I should probably be more embarrassed by that. All right, so we got that. So let's say that we then want to come in here and we want to get the very first thing stored inside of it. We can do that. We could also loop through our tuple, again, using each. So we're going to go each do. Once again, value is going to be the temporary storage space for each of the values in the tuple. And then we're going to output all of that information on the screen. And then there we are. That's going to loop through everything. I don't know, I just cover a whole bunch of other different things. We could also get the first value that is stored inside of the tuple. And we could just type in first, followed with a question mark. We're going to be able to, you can also do that with last. So you can go ahead and try that out. We're also going to be able to get our size for our tuple. And there we are, and if we run it, you're going to see all of that input that we have right there. All right, so quick rundown of tuples and some things you can do with those. Now I want to talk about procs. All right, so a proc is going to represent a function pointer. It's sort of like a closure, and probably easiest to understand just by creating one. This is how you go and create one. You're going to define right here the input that is going to be received, and I'm going to say that the variable name is going to be x, and it is going to be a 32-bit integer. And then you define inside of it what happens with said integer. So we're going to multiply that integer times itself. Well, we can then just simply come in and go puts and proc and call and 5 like that and run it. And there you can see it got our results. So it's a very easy way for us to perform, go and very speedily create a function. And since I'm talking about functions, let's go and get a little bit more detailed into functions. All right, so to define a function, let's say I wanted to create a function that adds values. You're going to type in def and then add nums. You're then going to define any parameters that you might have inside of it. And this function's pretty simple. And let's just go like this. And you can either return a value or not return a value. That's completely up to you. And it's going to automatically return whatever the last thing is inside of the function. I just like to use return just to be explicit about things. And then you can do something like puts, add nums, and 5 and 4 inside of there. And you know the input or the output you're going to get for that. But I want to show you something else. We can also pass in variables in, well, you know, I want to do another example here that's going to explicitly state that variables are passed by values and not by reference. So let's go and create a variable x is equal to 1. Then I'm going to create a function, and the purpose of said function is to change this value. So it's going to get past the value of x. I'm going to then say x is equal to 5. I'm going to change it, or at least I think I am. And then whenever I come out of my function, I'm going to say that I want to output the value of x. And that'll be a to be continued, because I also want to show you another one. It's also going to be possible for a function to receive a variable number of arguments using a splat, as it's called. So let's go and create another sum thing, and we'll go get sum, and then we'll put a splat inside of there, or a star symbol, followed by values. Then we're going to be able to do something really neat. We'll be able to say sum is equal to 0 and vals each and do, and then inside of or we will say val and another one like that, and then we'll go sum plus equal to and whatever the value of that is, end to end that looping structure. And then see, I said that you can just put whatever variable is last. You don't need to use return. Well, there you go. I just did that. All right. And then for our final example, we can say puts and get sum, and it has no idea how many different values are coming. We're just going to throw a whole bunch inside of it, right like that, and we will run it, and you will see the output. Whenever we add 5 plus 4, we get 9. Whenever we tried to change the value of x inside of the function, you see that it did not work. And right here, you're going to see that we were able to, whoops, I forgot to put this inside of there. Let's go sum instead. And let's run it again. And now you're going to see that it added all those values. All right, so some quick examples there and different things we can do with functions. And now I want to talk about enums. All right, an enum is basically a collection of names that are going to be associated with an integer starting at 0 unless you define another one. And let's go and create one. Let's get one that's called color. And inside of it, we can say that this is an unsigned integer, and like I said, by default it's going to give you a 32-bit integer, but we're going to use that. Then you just define inside of it what you want. So we're going to say blue, red. You're also going to be able to change the index if you'd like. So let's just change this to 4 just to change it. And if you change blue in this situation to 1, red's automatically going to become 2 and green become 3. And so forth and so on. And you're also going to be able to go and create methods inside of it. So let's say I wanted to create a method or a function, whatever you want to call it. And this function specifically is going to check if the current value is a green or not. If you want to reference the enumerated type itself, you refer to it as self because you don't know the name. And we're going to say color and green. So we're going to check if in this function, if whatever the variable is of a green type. So we'll close that off, and then we're going to go and work with this stuff. So we can say puts and color and green and value, and you're going to see the 4 comes back whenever we check that. And then we can also use that function we created inside there by going puts and color once again and green, and then we can go and call that function just by putting a period and green right like that. And we can check if it's green or not. And you can see 4 comes back because we defined 4 right here. And true comes back because indeed the type of green is actually equal to green. All right, so very simple example of enums. Now I want to talk very briefly about symbols, and then I'll talk more about symbols whenever we cover classes. All right, a symbol, sometimes people get confused by them. Basically, a symbol is just a string that can't change. And how you define one is like that. There you go, you just made a symbol. And I'm going to say puts, and if I specifically call for the, that Derek symbol that I just created, there you are, Derek's going to get printed out. All right, very, very simple. Now what I'm going to do is talk more about symbols here inside of classes. Now basically, I'm sure you're probably well aware that classes are just blueprints used to model real-world objects. And I'm going to cover inheritance and polymorphism and everything else, of course. And our object attributes, our real-world object attributes like height and weight and things like that, are going to be called fields. And our object capabilities like being able to run, eat, jump, and all those things are going to be called methods. So let's go and create a classic type of class, which is our animal class. Now you're going to define a function that is going to be called whenever you create any object of type animal, and it is going to be initialized. Inside of here, you're going to define any different attributes you want to set, like the name of an animal, and in this situation we're going to put in the data type that's associated with it. And in here what we can do is just print out a message, something like animal created, just to do something. If we then want to store the value that was passed inside of here whenever we created this object, we're going to use the @ symbol with name to specifically store it as the name for our animal object that we just created. We're also I'm going to show you a shortcut to go and generate the different setters and getters and things like that in our next example. But here I'll just, just so I can have some different methods to work with, I'm going to do it the long way this time. So here we go and create a method that's going to allow us to set the name. Let's go and create another one that's going to allow us to get our name, and to return a value, just put at and name and end. Very simple. We're also going to, let's go and create another way to get a name value. We can also just go define and name like that, and that is going to give us our name back if we put it in that order like that. And we will also be able to protect our name data. So we can say something like define name is equal to, and we can put name inside of there like this. And then we can say something like if name dot is a and question mark number. Let's say we don't want our animals to just have a number for a name. Well, we can go and put, define that right there. That's how we protect our data. And we can say something like print a message that says name can't be a number. And otherwise, if it isn't a number, we could then come in and say name is equal to name like that. And then we can close off both of those. And then we can close off our class definition altogether. And now let's go and create some stuff. So to create an animal object, we just define whatever we want our variable to be called, our animal object to be called, which is cat in this situation. And then we go new, and then because it requires it, we provide a name for our animal. We can also then, let's say we don't like the name that was given, we can come in and change it. Let's try changing it to 1, just to go and cause some problems. And then let's say no, they don't like 1 as an example, so we will then name our cat Sophie. That works. We can then also get the name that was associated by going cat and calling the function that we defined inside of there without parentheses. And I think that's enough for our example. And if we run it, you're going to see animal created because we went and called this line right here. It called the initialize, which is right up there. We then went and tried to change the name to 1. It said can't change it to a number. And then we went and finally changed it to Sophie. All right, so neat stuff. Let's do some more. I'm going to create a new class, and this is going to be called dog. And here is the shortcut way for creating getters and setters. You can go property and name and string and property and height, and let's say we want that to be a 32-bit float, and property and weight, and once again float and 32. Okay, so those are automatically going to create getters and setters. Once again, let's define initialize. And in this situation, we're not going to put anything inside of there. Instead, what we're going to do is give default values. So we'll go no name is going to be the default name that we would like, and height is going to be 0, and weight is going to also be equal to 0. All right, so very, very simple. And then what we'll do is we'll say something like bark. And in that situation, we can either put bark inside of there, or we could put return bark. It doesn't matter, do whatever you'd like. And then we can close that off. So there is our new class, which is dog. Now let's test this out. So we can say rover is equal to dog. We don't need to pass a name in this time because it wasn't required in the initialization for it. And then we can just say rover name is going to be equal to, you guessed it, rover. And then we can output some information. So we can do puts, and we can say rover name and says, and then we can call the function by going rover, and we can call bark. And there is that. And let's run it just to show you what happens. And there it is. Rover says bark. Okay. So, and the reason why animal created didn't come up is because we didn't have that in our initialize function for our dog. And there you are, just 2 examples of classes. Let's do some more. Let's go and inherit the fields from dog into a new class. How you do that? Let's say we go German shepherd, and if you want to inherit all of dog's stuff, methods and fields and such, you just go like that, and dog. Pretty simple. We can then overwrite something if we don't like what's inside of there. So we can say we don't like the bark function. We want to instead return loud bark. Okay, so bigger dog. I don't know. Something like that. All right, so we inherited all the other stuff and overwrote some stuff. And let's say his name is Max. And we can say that we want bird and then we are not going to do anything with it because we don't have the ability to change the name inside of there. And then we'll go max and name, and of course his name is max, and then we can go and output some information. So we'll say puts, and we'll go max and name and says, and once again go and get the new bark, which is max and bark, and we did it, and we ran it, and you can see max says loud bark. So that was how to inherit those different capabilities, but also overwrite those things we don't like. And now what I want to talk about are modules. Okay, so modules are basically going to allow you to add functionality to a class, and the only thing is a module cannot be instantiated, so you can't create a module object. However, unlike with inheritance of a class where you can only inherit one of them, you can actually inherit multiple modules. And how you create a module is, I'm just going to do a very simple thing here. I'm going to say module is vehicle, and then I'm going to define a function inside of it, which is going to be make sound. And then all it's going to do whenever it is called is it's just going to go something like room, okay? Just something. All right, and then we can close off that function and close this off. Now, if we want to go and inherit a module, so we can say class, and we'll say something like Mac truck, and to inherit, you just say include and vehicle in this situation. And then you can go end, and we inherited everything that was inside of that module. Now we can just go Mac truck is equal to Mac truck like this, and new, and then we can go Mac truck and make sound. So make sound like that, and if we run it, you can see that it does go room. All right, so there you go. There is modules, and I want to talk about polymorphism. Now, basically, Crystal is going to use duck typing just like Ruby does to achieve polymorphism, and it's probably best to see an example to understand this. So I'm going to create a class called bird, and I'm going to create a function inside of it called tweet, and we can go bird type, and we can say, and actually, normally, I probably should have talked about this earlier, but it doesn't matter. Normally, it's very common to use these underscores instead of camel type whenever you are working with Ruby as well as with Crystal, but I just chose to use this, so whatever. Okay, so I'm going to use it here in this example just so you can see. So we'll go bird type and tweet, tweet like that, and end, and then end that class. Now we're going to go and create another one, which is cardinal, and we will inherit the bird class inside of it. And now we will define tweet again, and we'll go puts, and we'll say tweet, tweet, okay? So there we are, and then we can close that off as well. And then let's go and create another one. Let's just copy this because it's basically going to be the same. And here we will just call this parrot instead, just to have something different. And then we will change this to squawk. I guess it might have made more sense to give it a different name than tweet, but anyway that works. Now what we'll be able to do is come in here and go generic bird is equal to, and you can see that we defined it as a bird object. And then we can go generic and bird, and then tweet like this, and then pass in cardinal new whenever we define this, and then we can come in and throw this inside of there, and then change this to parrot like that. And you can see that whenever we run it, whoops, I got an error because I'm supposed to go like this, underscore, and generic bird, and underscore like that. And let's run it. And you're going to see that we have tweet, and squawk inside of there. So that's how polymorphism would work inside of Crystal. And now I want to talk about structs. Okay, so basically a struct is going to allow us to create lightweight class type things with some built-in functionality. So let's go and say we want to create something, a struct called location, and you can use property inside of it as well. So we'll say something like latitude, and this is a float, and we'll go and create another one, and this will represent longitude like that. And then we can do initialize in it just like we do with classes. So initialize, and we are going to go lat and define the type that it is going to be getting, which is going to be float 32. And we can also come in and do longitude, and again float 32 works out in that situation. And then for our initialization itself, we're not going to do anything because everything is going to work fine just like that. Then we'll be able to go in and go define position, and we can output some information. So we'll say something like puts and latitude and output that. And then we can also go and get our latitude just by going lat like that. And then we can go longitude, and let's go and put that inside of there as well. So there's long, and then we will end the whole entire thing like that. And then we can go and create it. So we'll say something like where is equal to location, and see if you can guess where this location might be. And we'll go 80.31 and 72.62, and you could go and then we can just go where and position and then run it. Whoops, what'd I do? Location. So let's go location here and run it, and you can see that latitude and longitude prints out. All right, so very, very simple explanation and an example of structs. And now I want to give you an example of how we can use exception handling. All right, so we're going to catch exceptions with begin as well as rescue. So what we're going to do here is handle a situation in which the user tries to divide by 0. So we're going to say enter a number and ask the user to do said thing. And then we're going to store this in something called fnum is equal to, and then we'll go gets, once again, protect against nil and nil like that. And then we're going to do this 2 times. And then if the user goes and tries to enter in a value that is, let's go and put this as fnum, and then let's have this be second number, okay? So first number, second number. So then inside of begin, we are going to protect from a situation in which the user might try to divide by 0. So we'll go 2 and underscore I, and then we'll go second number, convert it into an integer. All right, so that's what we think we might get a problem with. Then rescue is going to provide us with an option to save everything. And you'd also be able to come in here and do something like rescue 0 division error or something, but I'm just going to keep it simple. And then I'll go puts, and I'll say, create an error that says something like you can't divide by 0. And then I'm going to throw exit inside of there, and then end. Now what I'm going to try to do is I'm going to go puts, and otherwise we don't have the error problem, so I'll go f number, and then you'll be able to see both examples. And then we'll go and do s number is equal to, and then we'll go and get our answer, and I'll put that on the screen, but don't forget to put your curly brackets inside of there. All right, and if we run it, you're going to see enter a number, and we can go 2, and then we'll put 0 inside of there. You can't divide by 0 pops up. However, if we go enter a number, do something like 10 and 5, you can see that everything works perfectly fine. All right, so that's the first example. Let me do you another example. You're also going to be able to throw your own exceptions with raise. So let's say we have age defined as -1. Well, here's a situation in which we might have a problem. So here we'll say if age is less than 0, in that situation, we're going to raise an exception. We're going to give a message here. We're going to say enter a positive number, and then we will end that. And then we're going to rescue that. We'll just put like a default EX in there for exception. And here we'll say puts, and that is an impossible age. And whoops. There we are. And then end, of course, to end that. And of course, if we run it, that's an impossible age is going to show up right there. All right, so there you are, 2 examples of exception handling. Now I want to finish everything off by showing you how to do some file I/O. All right, we're going to be able to read and write from files. What I'm going to do here is I'm going to create write handler, and this is going to return a file object that's going to allow us to write to a file. So I'm going to go file and new. If the file doesn't exist, well, I am going to create it. So we'll do something like we'll go some file, some file, and out, and then we're going to be writing to that file, so we have to put a W inside of there. So that's going to create that file for us. Now what we want to do is put some text in the file. So we're going to get our write handler and puts, and then whatever random text we want to put inside of there, which we are going to convert into a string. And then we can close our file and handler close. And then we can read data from the file. So we'll say something like data from file is equal to file and read. And then the file that we want to read from is called some file out. And you're going to see that it's going to output that information to our screen, because all we need to do is go puts data from file and then plus data from file. All right, and whenever I do that, random text is going to show up on the right side of the screen. So there you go, guys. There is a quick run through of the core syntax of the Crystal programming language. Hopefully this was useful to you. And like always, please leave your questions and comments below. Otherwise, till next time.